Great. Well, let's get started. We have only 10 minutes here. So I'm going to try to hit the high points. So this talk today is entitled SlimFast, Unleashing Speech Intelligence Through Domain-Specific Language Models. My name is Andrew, VP of Research at Deepgram. I would be remiss if I don't first tell you a little bit about Deepgram. We're a speech-to-text startup. We're mid-stage, founded in 2015. We're a Series B company, 85 million total dollars raised so far. So we have what we believe to be the best, most accurate and fastest speech-to-text API on the market. So far in Deepgram's existence, we've processed over 1 trillion minutes of audio. We have a lot of customers who we have delighted, and so I'm going to tell you about some things that we're working on and we're interested in today. So some of the things that motivate us. Here's some of our fundamental beliefs. The first one is that language is the universal interface to AI. So we believe that language is the primary way that we interact and carries the most amount of information, and will be the universal interface that will unlock the full potential of AI. And that is starting to happen now. So businesses are going to be able to realize the power of language AI, but we think that businesses need adapted AI to make it useful. So I'm going to start off here by first making some predictions related to language AI. Over the next 2 years, many businesses will start to derive tremendous value from language AI products. And in the short term, the most impactful products that people are going to build are going to combine existing technologies in a multi-model pipeline. So what does that mean? Well, this pipeline is going to have 3 stages in it. There's going to be a perception layer, which is going to be fundamentally ASR, something that takes audio and turns it into text. So a speech recognition system, probably complemented by a diarization system that predicts from that audio who is speaking when and allows you to format that transcript in a nice way to separate out the speaker turns. There's going to be an understanding layer that will take the output of that transcript and apply probably a large language model, or perhaps a medium-sized language model, or a small language model, some kind of language model that will understand what's said in that transcript and will produce some kind of distilled useful output, like a summarization of the transcript or a detection of the topics or the sentiment. Finally, you'll have an interaction layer, which will take, say, the output of an LLM, which is generating, say, a response to the audio input, and then we'll make that, we'll turn that into audio using, say, text-to-speech. Right? So we have this language AI model pipeline. So we think that businesses are going to derive maximum benefit from language AI products that are cost-effective, reliable, and accurate. Those 3 things together, you need all 3. And the purpose of this talk is to argue that this is going to require the use of small, fast, domain-specific language models, as opposed to large foundational language models. Right? So that's my thesis. We're going to argue this point in the context of a specific application, call centers. So what is a call center? Well, it's a centralized office or facility used by companies to handle very large volumes of incoming and outgoing telephone calls. Call centers are staffed with agents who are trained specifically to handle the customer inquiries that will be coming in, the complaints that might be coming in, and they're trained to provide technical support or sales or perform sales-related tasks. And their training will be specific to the business that this call center is supporting. So there's a number of AI products that are going to be built for the call center. Some of them are already being built and in their initial stages. These will be products that will help both the customer experience on the left to the employee experience, like the agent on the right. A couple of important ones would be voice bots or real-time agent assist systems. Other importance would be important ones would be audio intelligence features. So basically taking the output of many phone calls and summarizing them, or predicting the topics for them, or predicting the sentiment of the customer in those calls. So you might say, why not use a prompted foundational language model, large language model, to build language AI products for a call center? The first reason I would argue against this is the scale of large language models. They're ridiculous. 100 billion plus parameters. If you measure it in terms of how much resources it would require to launch this model with A5000 GPUs, it would require dozens of them. They're very small, or they're very slow, inferencing on the order of 100 milliseconds per token. So generating a long response might take many seconds. So just based on the scale and the inefficiency alone, you could argue against it. Looking a little bit more in detail at large language models and what they can do, they have broad general knowledge, and they can be aligned to do many tasks without explicit training. They do many, many things. However, conversational text generated by a call center has a high degree of specificity. It covers narrowly distributed topics. The people speaking have unique speech patterns associated with where they are in the world. And there's going to be a long tail of rare words that the foundational language model probably has never seen before. To get an idea of the task specificity that's involved, we could look at, say, the top 15 tasks that a call center agent would perform. They're very highly specific and yet complex tasks that require language understanding. Another point we can make is that domain-specific conversational text is generally out of distribution for foundational LLMs. We can get an idea of this by asking ChatGPT to continue a call center conversation. So if we give it a brief prompt, all right, with an intro by an agent, and then we have a customer who's starting to speak, and we look at the transcript that gets generated, we see that it's very unrealistic. The speech is way too clean, as if it were written, and the output tends to follow a predictable script of a greeting. Customer describes an issue, agent takes an action, customer accepts the action, and the call ends. Very unrealistic. If we look at real examples, we see that they feature things like crosstalk, people trying to talk over each other. It makes transcripts very difficult to read and interpret. Real transcripts have things like disfluencies, where people are basically stuttering and stumbling while they're speaking using filler words. That also makes transcripts hard to read. So we argue that we should shoot for domain-adapted language models for call centers, and that these models can be small. To prove this point, we took a small language model, 500 million parameters, that was trained on general internet data. And then we transfer learned it on an in-domain data set of call center transcripts. We found that the model improved dramatically in all metrics, next token prediction, loss, and perplexity. And when we use it, we find that we can continue a call center conversation, a prompted call center conversation, and it generates very realistic text. And then we have gone further and used that to train a summarization model, which I'll demo to you now in this Jupyter notebook. So we're going to make 3 calls here. We're going to first make a call that, so we're going to call a function that hits the Deepgram API, transcribes an audio, a phone call audio, diarizes the transcript, and then sends the transcript to our SLM to perform summarization. You see that that call took 8.4 seconds. We're going to print the transcript that we got back from ASR and diarized. We see that it's highly accurate, and we're going to print the summary that we got back. And we see a very nice human-readable summary that is actually quite accurate, describing what happened in this call. And that's what I have for you folks today.